It's a sunny day at a playground. And this is Kevin.
Hi, may I join you guys?
Actually, we were just about to leave. Damn, did you see the size?
Oh man.
Here comes Kimberly. They look at each other awkwardly.
Would you like to join me?
Yes, of course. But it's not really moving.
Try sitting in front a little.
It's working. But why does it work?
Moments.
Let
me explain. You've heard of forces, right? Objects with mass experience a net force if they have acceleration. Just like this popcorn. It'll only experience a weak force. Now consider this cannon. Boom! Similarly, you exert a force on a seesaw. You have a mass of 100 kilograms, there's acceleration due to gravity, so there'll be a force of 1000 newtons. But because there's a pivot, you're actually generating a turning effect. And this is called a moment.
Okay.
Moments can be calculated by multiplying force and perpendicular distance. Let's try it. You exert a force of 1000 newtons, and the perpendicular distance is 0.3 meters. This gives us a moment of 300 newton meters. What if we increase the perpendicular distance? We see that the greater the perpendicular distance, the greater the moment. These everyday tools increase moments by increasing perpendicular distance. Think about how hard it'd be to open a bottle with your short fingers. Now back to your question. Here, both of you are exerting moments in opposite directions. Kimberly is producing a clockwise moment, while Kevin generates an anti-clockwise moment. How can we balance the moments? First, we can reduce the force. Second, we reduce the perpendicular distance. When anti-clockwise moments equal clockwise moments, equilibrium is reached.
Cool.
Now try this problem. There's a 90 centimeter beam on the pivot. There are some moments acting on it. To keep the beam balanced, what should force Z be? First, we change the units into meters. Then, let's identify the clockwise and anti-clockwise moments. Pause to see if it makes sense. Lastly, we solve for Z. Got it? Here's a trickier one. A barrel has a weight of 300 newtons, and here are some other measurements. If a horizontal force X is applied to the barrel, what's the smallest value of X to make it roll up? First, let's identify the pivot. It's here. Now, what are the clockwise moments? What about the anti-clockwise moments? Great. Lastly, we equate clockwise and anti-clockwise moments and then solve for X. Okay, now you know.
Kevin and Kimberly go for some ice cream to celebrate the moment they met.